Okay, now here is the calculator portion. So Unit 7, ChA calculator portion. We give you a graph and we say match it to the correct function. So which one of these functions equals this? Well, first off, none of these have any shifts. So that means it's not shift up, down, left, or right. So it's really just a b to the x. So a is the initial value. So look at your graph here. Where is it crossing the y-axis? That's at 1. So y equals 1 times something to the x power. Doesn't really narrow it down because all of these have 1s in front. Now, these have negatives, so I can throw those out because it's not the negatives, it's a positive. But what I want to know is, as I go to the right, is it decreasing or is it increasing? Okay, so this one, if I go to the right, it looks like it's about 1/3 of what it was before. If I go to the left, it's 3 times what it was. Okay, so from left to right, I'm going down 1/3 every time. So from 3 to 1 to 1/3, that means I'm multiplying by 1/3 every time. So it'd be letter B. Number 2, convert to an exponential equation. Log base W of Q. Well, W is the base, 3 is the exponent, and then the answer is, is Q. Put theta there for a second. So W to the third equals Q. So for me, that was my A. Number 3, you got to rewrite using the power and product. So basically expand is what they're saying. So I need to expand this. So I got y times z to the 6. Well, if there's a times in between there, I can split them into 2 different logs with an addition between them. So log base b of y plus log base b of z to the 6th. So split the y and the z to the 6th, and then the 6th comes out front. So log base b of y, so it looks like letter B. Log base b of y plus 6 log. Yep, so letter B. Number 4, I'll use some scratch paper for number 4 here. Half-life. Okay, so it says half-life of caffeine is 6 hours. You're going to start with 150, so that's your initial value is 150. And then we're going to multiply by is a half. But I don't want to do it every hour. If I did it every hour, that means my half-life is 1 hour. So I don't want to just put an X up here because that means every hour the amount of caffeine will be cut in half, and it really should be every 6 hours. So you can think of every hour would be 1/6 of a half-life, and then after 6 hours it would be 1 half-life, so 6 over 6 is 1. So this is the equation where x, whatever time I'm trying to find, so if it's 12, I'm going to put a 12 in there. So I'm going to scratch this out and put 12. So you type this in the calculator, 150 times 1/2 raised to the, and then you may want to put that in parentheses just in case. Some calculators you have to put in parentheses. If you want to do that in your head, 12 divided by 6 is 2. So you're going to take that second power. This one is, see, the amount would be 37.5 milligrams. So again, that's number 4. Number 5, let's switch these up here. I'll go like this. But number 5, the amount A of 200 grams of a certain radioactive material remains after T years, and you use this equation. When will 100 grams remain? It's basically when will it be half? Okay, so the initial amount is 200, 0.75 to the T, and they want to know when it'll equal 100. So now I need to solve for T. Anytime the variable is in the exponent, you're going to have to use a logarithm at some point, because a logarithm gets rid of the base. Well, this is my base and my exponent. I need to get it by itself before I even think about using a logarithm. So I'm going to divide by 200 on both sides. So 1/2 equals 0.75 to the T power. And then to get rid of that base, I'm going to use a log with 0.75. So log 0.75 on both sides. So this would just equal T. And on this side, change of base says log of 1/2 divided by log of 0.75. So in the calculator, you're going to do change of base. And this one is 2.41. So 2.41 years until it's, so you got half. Okay. Number 6. Let's see. Yeah, better use scratch paper. So number 6. Small town, the population decreases 4% every year. We start with 160. How many years until it's 100? So we're supposed to first write an equation. So that part I could probably do right here. So I'm going to start with 160. If I lose 4% a year, that means I'm keeping 96. So 0.96 for every year. And then how long until that equals 100? So that would be my equation to put in there. Now if I want to solve this problem, 100 equals 160.96 to the x. Divide both sides by 160. This one, if you want to be 0.625. To get rid of that base, use a log with the matching base. So log base 0.96. Log base 0.96. So that equals x. And on here, change of base, this goes on top, the base goes on bottom, and that's going to equal 11.51. We put it in the calculator. Okay, so that's number 6. So number 7, make some space here. So you're investing $3,000 at an interest rate of 4% compounded annually. So annually means n equals 1. So you can use this, but you don't really need to use, because if I put a 1 in here and a 1 up here, that means it's not needed. So I got $3,000. It's going to go 4% annually, so 1.04 to the x, or to the t. You can put t there. How many years until it's 5,700? So 5,700. So first one, divide both sides by 3,000. I'm actually going to do this. I'm just going to reduce that to 57/30ths. So I'm going to say 57/30ths equals 1.04 to the x. And to get rid of a base, use a log with the same base. So log base 1.04 on both sides. And change the base for this would be 57/30ths on top, and then 1.04 on bottom. And when you put that into the calculator, 16.4. It would be 16.4 on that one. Number 8. So move things around here. Number 8, use the appropriate formula, which this was on the top of your page. So this one, we got 28, so this is number 8. Number 8, 28,000, 1 plus 3.95% is 0.0395 divided by, A is going to be daily, so 365, and then 5 times 365. Okay, so you put that in a calculator, you get 34113.52. And then for part B, this one is continuously, so you're just going to use E. It's going to E to the rate was 0.0395 times 5 years. Okay, so put that in the calculator. You get 34113.88, so not a big difference. There's not a huge difference between daily and continuously. Some pennies there after 5 years. Okay, now number 9. You need to solve this equation. So log base x of 1,024 equals 5. So the base is x, the exponent is 5, and that equals 1024. So what number to the 5th power equals 1,024? We could literally take this to the 5th root of both sides. So this would just be x, and then the 5th root of 124. So the 5th root of 1,024 is 4. So it'd be B. Number 10. Don't want to count down, I want to count up. Number 10, I got 8 to the x minus 3 equals 472. So My variable is stuck inside of the exponent, so I need to get rid of the base. I get rid of the base by doing log base 8. So log base 8 of both sides, log base 8. So on this side it'd be x minus 3. Over here I've got log, so change of base, 472, 8 on bottom, and then when I get that answer, I'm actually going to add 3 to it. Let's go like this. So I'm going to add 3 to it. So when I type this in the calculator, type it in, do the change of base. Log 472 over log 8 is 2.96, and then add 3 to it. So x equals 5.96. Let's go to 11. I'm going to the book right here. 11. So I'm supposed to do log base 3 of x minus 2 plus log base 3 of x minus 8, and that equals 3. So if I got two different logs on the same side and they have the same base, I need to condense them. So I'm going to write 1 log base 3. Okay, this is number 11. And since it's an addition, I need to multiply these together. So it would be, if I have x minus 2 times x minus 8, I'm going to FOIL those. So x times x is x squared, minus 8x minus 2x is minus 10x, plus 16 equals 3. Now, to get rid of that log base 3, use a base of 3. So I'm going to take 3 to this power and 3 to this power. We got x squared minus 10x plus 16. 3 to the third is 27. Okay. Now, if it's a quadratic like this, bring the 27 over. So I'm going to subtract 27. So that'd be minus 11. So I want to factor. Okay, so if I got negative 10 and negative 11, so the product is negative 11, the sum is negative 10. I'd say that is negative 11 and positive 1. So the product is negative 11, the sum is negative 10. So it means x equals 11 or negative 1. Don't just circle those answers though, because I'll look at the original equation. If I plug these in, is the argument still positive? So if I plug 11 in, 11 minus 2 is 9, that's positive. 11 minus 8 is 3, that's positive. So 11 works. Negative 1. Negative 1 minus 2 is negative 3. I can't take 3 to any power to get negative 3, so the argument cannot be negative. So I've got to throw that out. So it would just be 11 for that one. Okay? And then the last one, number 12, I've got 6 e to the 4x equals 972. Now I want to get rid of that e. Before I use a logarithm, I got to make sure that the base and the exponent are by themselves. And they're not. They got a 6 out here, so divide by 6. So 972 divided by 6 is 162. Now, to get rid of the e, I'm going to do natural log. So natural log of both sides. So this is gone. I got 4x equals a natural log of 162. Divide both sides by 4. So this is the exact answer. And then type it in the calculator and do natural log 162. Divide that by 4, and it should be 1.27. Round to 2 decimal places, so 1.27. Okay, so this was the end of the this is the end of the calculator portion.